Hello, statistical scholars, and welcome to Data Analysis 6, the Minitab Express edition. Hey! I've got the data analysis number 6 examples for confidence intervals and sample size set up in my left panel, and over here I've got some Minitab Express. I've cut off the top half where up above here where it's got like save and print and junk because I'm not going to need any of that. Um, so instead, I'm just going to be calculating these examples today that already have the solutions up there, but I thought I'd show you the steps behind doing the mini tab for them. So the first example we're going to look at is out of 128 randomly selected adults, 23, 32 were found to have high blood pressure. Find the point estimate for the proportion of all adults in the United States who have high blood pressure. That's just your sample proportion for the point estimate. Remember, it's a single estimator. So what you want to do is you want to take 32 and divide it by 29, which would give you about 24.8. The reason I did 3 decimal places here so that when you round it, you get 1 decimal place on the percentage, which is a really common way of writing percentages. So now we're going to construct the 95% confidence interval for the true percentage of all adults who have high blood pressure. So to do that, we're going to tab over to the statistics tab. And we're going to go down to inference because we're on the inferential end of statistics now. And we're going to hit one sample and we're going to go down to one proportion since we're dealing with a proportion or a p. Alrighty, and so here it thinks my data is in a column down here, but it totally isn't. So I'm going to change this to summarize data. And I need to put in the number of positive events that have happened. So we count it positive that you have blood pressure here, strangely enough. And the number of trials I'm looking at is 129. And I'm not performing a hypothesis today. I'm just performing a confidence interval. I need to check my options to make sure my percentage is correct. And I want to change this from exact method to normal approximation because proportions behave like a binomial, and if you use the exact method, it's going to use normal and not the binomial approximation for the normal, which this is going to give you something more accurate. Anyway, so the other thing that's important is you leave this as a not equal to, because if you change this to a left or a right, it'll only produce one end of the interval instead of both. So we're going to go ahead and hit OK. And there's your confidence interval. For some reason, Minitab Express also likes to produce a graph, because you need that. You don't really need that. Okay, so there's the confidence interval for P. So this is the population percentage that we suspect has high blood pressures in adults in the United States is somewhere between 17.4 and 32.3%. This output is from Minitab 17. Notice they come out exactly the same. Baller. All right, let's do example number 2. In a survey of randomly selected subjects, the mean age of the 36 respondents was about 40 years and the standard deviation of 10 years. Use the sample results to construct a 95% confidence interval for the mean age of the population from the sample in which this is selected. This is useful if you were maybe doing like a survey on people who visited your store and you want to know what age group does your store appeal to. So we're looking at means, so I should probably be doing means, and I have a sample standard deviation and it's a confidence interval, so I'm going to be using t since I don't have the population standard deviation. I just have this one from the sample. So we're going to go to one sample, we're going to go down to t, which is our first option in means and variance, and it still thinks I'm in data in a column, so I got to change that to summarize data. Got to put in my sample size first, words. Then I got to put in my sample value, and then there's my standard deviation. And then I got to go to my options, and I want 95%, or did I want 99? Nope, 95. All right. Mean not equal to. Oh, good. This is unchecked. I was going to check to make sure I wasn't having any pictures. So again, 95%er not equal to. Otherwise, it'll only produce one side, not both. And then double check all my values really quick. Looking good. Not doing a hypothesis test. Let's hit OK. There's the one sample T for you. There's our sample size, mean, standard deviation, looking good. Standard deviation for the mean, so this is the standard error of the mean. This is the standard deviation of the sampling distribution. So this is just that standard deviation divided by the square root of the sample size, in case you were wondering what that value was. And that tells us the mean age is somewhere actually for the entire population between 36.6 and 34.4 years. Example number 3. So suppose we take a random sample of 94 light bulbs, because that's what we do with our time when you're doing stats, and you find that the mean lifetime is about 587 hours. Assume that the population has a standard deviation of 36 hours. Construct a 90% confidence interval for the mean life of all light bulbs of this type. Now, I have the population standard deviation. That's a big clue that I'm going to be doing a Z, not a T. Also, since these are all means, definitely these two, not that one. All right, I got to do a 90%er this time, so I got to change my confidence value when I'm doing this. So I'm going to go to one sample, going down to Z, or over to Z rather. Oh, I got to tell it my data is not in a column. I got to put in my sample size, 94 light bulbs, 587 hours. My known standard deviation is 36 hours. And I got to go to options to change this to a 90%er. Notice I just typed this in here. You don't have to actually do the drop down menu. Fun facts of the day. Let's hit OK. And there are our values. Okay, so then again, sample size, mean, standard deviation for the sampling distribution, also known as the standard error of the mean. Wow, it's annoying that I keep doing that. Lights on, lights off. Oh, lights off. Okay, because they die. All right, whatever. It appears that your light bulbs typically have a life, an average life, sorry, of 580.89 hours and 593.11 hours. Fun times. Okay, let's research some things. A researcher wishes to determine the mean amount of time the American teens spend each week using the internet. How many American teens must she sample? She wishes to be 95% confident that the sample mean is within 0.5 hours of the true mean. Assume the initial survey indicates that there was actually a sample standard deviation of 6.6 hours. So I'm actually going to shrink Minitab for a minute and pull up my Webbit. Run it. Oh, this is going slow. All right, clear that sucker. So I'm going to actually physically calculate this. So we want to find the sample size n and need to estimate the population mean. So I'm going to use the fact that I'm going to use my z-score times my standard deviation divided by my margin of error. So I'm going to put it in parentheses. And I want to do 1.96. I hit the wrong button. Sorry. 0.96 times 6.6 divided by 0.5. Close my parentheses. Oh my gosh, I gotta learn not to use the keyboard on this. Close my parentheses and then square it. $2 to donuts. Half of you are going to yell at me that I need to put parentheses on numerator. I actually don't. I'm going to prove that to you real quick. Let's hit enter. Look at that. Good times. Okay, real quickly, for those of you who don't trust me and think that I'm totally balls to the wall crazy for just putting this in order, if you understand how fractions work, since these are both in the numerator, another way you can think about this is 196 over 1 times 66 over 1 times the fraction 0.05 in the denominator with a 1. You multiply all those numerators together and then multiply the denominators together, you get your numerator and your denominator, and then it doesn't matter. But if you think I need that, let's insert them, and I'll prove to you that you actually don't. Now, if you have multiple things in the denominator, you definitely would need them on the denominator only. Ha-ha! Alright, so suppose you put in that. Uh-oh. So here I've got parentheses around my numerator, divided by the 0.5, then squared. Have at ye! It is the same! I like numbers. It's cool. You like whatever you like. I never get to talk to you. You should come see me sometime. I hang out at my office and talk to myself a lot. I'm not talking to myself. I'm making a video. Anyway, as always, we always round this up. So we're going to treat this as 670 people instead of that. Okay. So, number 5. I have a hard time with that word. Economist. Sound British. You'll be good. Wishes to estimate the proportion of Americans who own their house. What size sample should be obtained if he wishes to be within 3% points and within a 90% confidence level? If he uses a 2000 estimate of 67% obtained from the U.S. Census Bureau. So that's his p-value if he uses this estimate. So that's where that p is coming from. And then we have the z-star coming from up above. In case you didn't notice, I gave you these table values up here. A 90%er is 1.645. I've used these so much that I have them memorized, which is sad. I need to do other things with my brain power, but it's okay. I teach math, so it's kind of helpful. And I mean, you can look up those values. I've given you them like 4 places. They're not hard to find. Anyway, my margin of error is that he wants to be within 3%, so that's where that 3% is coming from. And this 0.33 is 1 minus 0.67, because that is your Q, your failure. All right, you multiply all those together. Don't forget to square. and you get 66 for, and then some stuff, and you don't even care what the stuff is, you always round up. 665! Woohoo! And that's if you're using a previously obtained value. Now, if you don't have prior knowledge, aka he does not use any prior estimates, we assume the worst case scenario is then, and that's that P is 0.5 and Q is 0.5. So here our P and our Q change, but this value is staying the same, which gives you that 751, sorry, 0.6, I don't even care what this is, we're going to round up, 752 Americans. If you want to see how to enter that into your calculator, I would do it as 0.5 times 0.5 times, and here I would use parentheses, numerator 1.645 divided by 0.03. I use a 0 there just to keep it, organized with my decimal. Square that action, we're ready to go. Now, if you're wondering, the TI-83 calculator does know that it should square first and do things inside parentheses first. So I don't need to actually physically do this first and then multiply all this stuff. It actually knows that part. So it's doing this inside first, then squaring it, and then doing multiplying because it knows the order of operations. There's that action for you. Why do I keep saying action? I need to. I don't know. Anyways, that's how you do this for Minitab Express. Enjoy! I can't find my stop button. Ha ha!